Hello everyone, this is a video lecture for Business Calculus Math 1325, Section 9.2, Infinite Limits. So, we're taking the limit with infinities, or we get an infinity answer. So, we already saw this a little bit last time, but I just really want to give you just an example of what's going on here. So, we have the limit as x approaches infinity of 3x minus 1 over x plus 4, a little bit better 4 there, is equal to blank. And it says go. Figure it out. I want to show you some awesome math skills here. I do. But first, we should definitely go to the graph. So let's go to the graph. And that was the graph from last time. Let's do a new one. So I got 3x minus 1 divided divided by x plus 4. Cool. So this is our graph. And I want to know, as we keep going towards positive infinity this way, so there's 100, 150, 200, 250. As I keep going this way, what is the height? What's the y value? And if you go back and you scroll in here, it looks kind of obvious. So that's 1, that's 2, that's 3. 3. Look, what's the height right here? 2.97395. It's basically just 3. So my answer is a 3. Just looking at the graph, it's a 3. As like for notes, which, notes are cool. I have a vertical asymptote here, and it does something like this, and we'll just keep seeing where it's going, and that's at y equals 3. It just basically the height is 3. So that's easy, right? Not too bad. Oh, I guess my graph was wrong. I flipped it. No. Do I have an eraser with one of these guys? Here, hold on. Oh, look at that. Well, it's the same answer anyways. Whoosh, there you go. Where's it going? Y equals 3. All right, well, it's either way. I guess my graph was wrong on my paper. I should probably fix that. What do you think? It doesn't matter, Chad. I already see the answer. So there you go. As you can see, these videos are not super formal. I think that they're a level above live stream, but they're not really well edited, and that's okay. You're getting the fresh, new hotness here. You know what I mean? So we got 3 as our answer. Cool. Now I'm gonna do a new technique, and if you're a math person, like a legitimate math person, like, I don't know, one of my co-teachers or my boss, I'm sorry, but I'm just going to have to do it. Yes, I am going to plug in infinity. Oh, Chad, you cannot do that! So I'm going to plug in this infinity like we do for everything else. Now, you can't do that in Desmos. That doesn't understand that. But I do want to show you how you can do it mathematically. So 3 times infinity minus 1 divided by infinity plus 4. Okay, what is infinity? Let's talk about infinity for a second. It's a really big number. Like here, I'm gonna say let's do an infinity amount of dollars, and there you go. It is okay. So that's thousands, millions, billions, so $100 trillion. That's infinity. I guess, yeah. So it's like a whole bunch of something, and it's just huge, 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 huge. Okay. So think of like a really huge number. How much money Bill Gates makes or something. I don't know. Huge amount of something. Okay. So, and then you're saying, I got 3 of them things. So there's like 3 Bill Gates, and they're making infinite money. That's a lot of money, okay? And then minus 1, because he bought a Snickers bar. Yeah, he bought a Snickers bar. He went to the store. He said, I have $100 trillion in my account, but I need to spend $1 to get a Snickers bar. Bill Gates is still a 100 trillionaire. You know what I mean? It's that minus 1. It just doesn't matter. Or here we have infinity, $100 trillion, and then someone says, hey, bro, I remember back in the day that you loaned me some money, so here's $4 back. And they're like, I have $100 trillion. Why are you giving me $4? I don't really care. you're still 100 trillionaire. You know what I mean? That doesn't matter. That's insignificant. And so we got 3 Bill Gates divided by 1 Bill Gates, okay? Infinity symbols? Well, you can see here that these actually cancel. It's kind of like an X, you know? So the X's cancel. Well, infinities are going to cancel. It's the same kind of math here. And what's your... Oh my gosh, it's a 3! So is this a legitimate way to do math? And a lot of mathers are saying, no, you can't do that. I'm gonna say that it's a way, it's a concept. It's a concept to understand that even math at this level, still you can do math. Okay, so you just have to kind of see the concepts. Okay, so enough with that. I'm not going to use that very often, if at all, but I wanted to show it because I can, and this is my class now. Ha 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 ha. So 9.2.9. Again, if you remember, I'm doing the ID numbers from the homeworks, okay? So, and I'm going to graph them as best I can. This is definitely not going to be perfect. There's this vertical asymptote, and then we have a thing that does this. It looks like it goes to -4. That's the answer. And then we have some kind of parabola thing. I don't really care. And it says, what's the limit as x goes to infinity of this function? And you see where it's going, right? It's going this way. That's positive infinity. So yay, we're going the right direction. What's the height? It's -4. Woo! All right, cool. 9 to 13. So for this one, I have a vertical asymptote here at -2. Let's keep that in mind. And I got this little parabola thingy, and then I got this little, I don't know what to call it. I just called it a, I don't know. I'm trying to make it a little bit fun because I think the last video I was getting a little frustrated, and there was that phone call. But this time here, it's going to be fun. This is actually going to be a fun class together because we're going to make it fun. So, x equals -2, and I forgot to write down that this is on the left side. So this is on the left side. And so, again, this is my dividing. We got the left side, we got the right side. And they say on the left, so I don't really care about any of this stuff here. I want to get really close to this line. And what is my y value? Where are we going? We're going to positive infinity. There's your answer. Ta-da! Okay, cool. Turn to page 9.2.25. So we have p of x is equal to 15 plus 4x to the 6 minus 5x to the 7. And it says, first off, what is the leading term? There's no other questions like this on your homework, so we have to talk about it. I mean, I don't know where you're coming from. I guess I could suppose that you should know this stuff, but I don't know. So let's talk about it. This is your leading term because it has the biggest power. I like to call him the boss. So he's the boss. He's got the biggest power, right? The boss has the most power. And if you can see, we're also looking at the leading coefficient and the degree. So in the front, what we have is a negative number, and for the power, we have an odd. And so I don't know what this graph will look like, but in the end, negative odd looks something kind of like this, and there you go. But it's these endpoints that I'm really concerned about for this kind of graph, okay? Negative odd, you do this. You do that, okay? Positive odd, you flip it. Evens are going the same direction. Anyways, so part B, it says, what's the limit as x goes to infinity of p of x? And so they're just trying to say the far right side. The far right side. They're saying, as we go this way, where's my y value? Again, this is a y value. Well, if I'm going this way, you can see that, well, it had gone way down, way before then. Down, 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 down. Down. Okay. Part C. Hey, what's the limit as we go to negative infinity? And again, now we're saying it's the far left side. That's what they're trying to say. We're going this way. Where's it going? Well, you can see it's going up in this case. Up, 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 up. There's your answers, up. You type positive, or you type infinity. I don't know if it accepts the positive in there or not. Who knows? It's my math lab. Sometimes it'll accept it. Sometimes it goes, no, that's not simplified. You just can't tell sometimes. So we have this big function here, and every one of these problems, man, is a little weird. So it says f of -6, figure it out. Whew, I am so glad that we have Desmos Scientific right here. So let's do that. So 9x cubed minus 18x squared. Whoa. There you go. 12x to the 4 plus 6, and x equals -6. Wha-bam. I mean, that was... Wait. That doesn't look right at all. And, you know, I thought about it, and I went back and looked, and I tried it on the homework. And, yeah, it's totally correct. On the homework, it says round to whatever many decimal places. Blah, 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 round. Decimal places. Yeah, that's what they wanted. All right, cool. Hey, go ahead and plug in a -12. Sure. Like, I don't know why they're wanting me to do this, but I can definitely do it. Hey, look, I got a decimal. Sweet. Why do I got a decimal? I don't know. And then finally at part C, it says, hey, what's the limit as we go to -infinity? All right, I got to say, they made a pretty poor decision here. Yeah, they made a very poor decision. They said, hey, yeah, we need to plug in a -6 and a -12. How about 12,000? Yeah, that's actually a lot closer. That's probably maybe too much. Let's back it up. Back it up. Back it up, Chad. Back it up. Back it up. So if you plug in a really big number, you actually start to see what they're trying to say. We're trying to go towards -infinity. And so they're going from -6 to -12 to like -120 to what's the value actually approaching? And you can see that's getting smaller and smaller, right? Smaller and smaller, especially when you put in all this. That right there with the little negative up there, that says that it's a small number. Smaller, smaller, smaller. You keep doing it, and... well, that means it's getting smaller. It's getting really small. I figured it would give you 0 at some point. Hey. Anyways, the answer's 0. So, there you go. Yeah. And you can graph it to go and see. But the point is the bigger my number is, the smaller it gets. Yeah. There you go. Oh, I did some infinity math here. Okay, I'm looking at my notes. All right, so if you don't believe me there, then let me do my cool infinity math here and get yelled at for it. So that's fine. So 3 times, or I'm sorry, 9 times infinity cubed, and then we got infinity squared. Yes, all of this will make sense here in just a second. So, think about it for a second. We don't have 3 times infinity. We don't have 3 Bill Gates. We have Bill Gates times Bill Gates times Bill Gates. Like, it's exponentiatingly large. Okay, if you have like $1,000, now you got like a bazillion dollars. Okay, you're tripling it. Not even tripling it. You're cubing it. It's more than that. Like, here, let's just talk about like big numbers. You say, hey man, go ahead and tell me what's a lot of money to you, and it's like $1,000. All right, cool. So then let's take that and say 1,000 times 1,000 times 1,000. Whoa, that's huge. And that's my point here, is that we're getting huge, 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 huge. So this is like huge cubed. It's huge. And then you got huge squared, still pretty big, but this is way bigger. If he's way bigger, he's the boss. And same thing here, add $6, who cares about that? And so ultimately we got 9 infinity cubed over 12 infinity to the 4. And you know what to do here. I mean, in a way, without all these silly notations, we got infinity, infinity, infinity. And then here we got infinity, 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 infinity. Cancel, cancel, cancel. So we're left with 9 over 12 with an infinity down here. Essentially, it doesn't really matter what the other numbers are. You got something over infinity. 0. And that's the same as what we just had a second ago. And let me prove 1 over infinity to you, at least show you. So we're going to do like 1,000. Just give me a 0, Desmos. Come on. Come on. Give me a 0, Desmos. Oh, you're just being a stinker. Look at this. It just doesn't stop. So, whatever. It's 0. So sometimes the calculators just don't want to cooperate with you. Here, I know. Round to like the nearest two decimal places. Just 2 is fine. So 9 to 53. I got f of x is equal to 3x squared plus 25 all over x squared minus 25. This one, again, I want to do weird questions that pop up. They're asking for the horizontal asymptote. And, well, this is, again, where I don't know what you know. At this point, have you seen horizontal asymptotes? Have you done the 3 rules, which I call them at least? I'm hoping so, but let me just talk about how that's going to go here. So there's 3 rules to horizontal asymptotes, and we're looking at the degrees of the top and the bottom. So rule number 1, if the degree of the top is less than the degree of the bottom, then your horizontal asymptote is y equals 0. Okay, that's the answer. Rule number 2, if your degree of the top is equal to the degree of the bottom, which is here in this case, then your horizontal asymptote is what I would say the front fraction. The front fraction, okay? And we're going to talk about what front fraction means here in just a second. I'm sure you got that, though. And then finally, top is is greater than the bottom. Then there's just no horizontal asymptote, and that's kind of like your answer. So those are the 3 rules really succinctly. And so we're saying the front fraction, you're looking like right here. And what is the number right in front of this x? It's a 1. What's 3 divided by 1? It's a 3. Now, how the homework wants you to type it is y equals 3. They require you to include the y equals because they say it's an equation. So there's that. Part B, they ask for the vertical asymptotes. Okay, I know my handwriting's pretty bad, but that was even worse. Vertical asymptotes. The formula for this is a lot easier. It's when the bottom is equal to 0. You have to like simplify it and stuff, but I mean, it's just take the bottom, set it equal to 0 at this point. So x squared minus 25 is equal to 0. X squared is equal to 25. You square root both sides, and you get plus or minus 5. And that's actually the answer, the way they want it, I believe, the way I wrote it at least. It looks something more like this, with a comma between them. Or there's like 2 separate boxes, and you have to put 5 and then -5 or -5 and then 5. I don't know. There's your answers. There you go. Cool. We're actually really close to the end. I think I only got 2 left, and they're pretty short. So 9 to 67. They say find the limit as x goes to infinity of this big guy. Again, what you're doing are horizontal asymptotes, essentially, and I'm going to emphasize that on this problem. So we're looking for the answer. Notice that the top is bigger than the bottom, and there's no horizontal asymptote. And what that really means is that you should be getting an infinity or something, maybe a negative infinity. To do the math on this one, just the infinity math, and I know this is silly, but I mean, hang out with me for just a second here, okay? These don't matter because they're not the boss. There's 7 in the top and 6 in the bottom. And so you have an infinity in the top, which, well, that means it's infinity. So there's your answer. It could have been a negative if there was a negative up here somewhere, but that was not the case. Last question. And I got this one wrong, and I was staring at it forever, and I figured it out finally, and ooh, it was just so annoying. And that's why I'm doing these homework problems because, gosh, if I were to just leave you out there hanging, you would be very frustrated and say, why is this not working? Like I do. And so, like, it's my job to be frustrated like that, you know? And then finally, I figured it out so that I can kind of tell you where to go, that kind of thing. It's okay for you to just be, to be like struggling a little, you know? But if I'm struggling, then there's definitely a problem, and that's not good. So that's why I'm here to help you in a lot of these things. So we got fixed cost is $400 a day, and then we have the total cost. Total, just kind of total. Okay, we're gonna definitely revisit that word here in a few minutes. Is equal to 5600 per day. Okay, yep. when making like 20 boards a day. I don't write all these word problems down, so we're talking about like dollars for boards or something. I don't really know. And they say that this part here is linear. They say this is linear. Okay. So let's figure out what they're trying to say here. They say find the cost function at all. So we have a fixed cost of $100 a day. It's like keeping the lights on and paying the employees and all that kind of stuff, rent, things that just don't change. And then you have the total cost when you're making 20 boards. So that's like the materials for the boards and whatever else you're doing for that. But they say it's linear, which means that we're going to follow this MX plus B format. Now, I'm not going to go down that road too much, but that's kind of what they're saying here. And we want this find a slope kind of thingy. Well, this is how I approached it. This is how I did it finally after getting it wrong. I said, well, I know there's 400 each day. Okay, so we definitely got to pay 400 each day. That's not a problem. And then I need to pay some amount for like board material and stuff. And so because this is the total cost for that, it's already including the 400. Okay, it's already including the 400. So what we're really seeing is that it was 5,200 for the boards alone. Okay? And so we have our 400 fixed costs already taken care of. Therefore, I'm only saying that I got 5,200 for the 20 boards. For however many more boards I will make. Okay, that's your answer. And so if you like simplify that, that comes out to be 260. And this is what they want for part A. Okay, so there it is. Average costs, and again, this is more of a definition more than anything. It's cost divided by X. So I take whatever I had, oops, 400, and then I'm going to divide it by X. That's your answer. You're done. That was it. So just watch out for that little guy. It happens. It happened to me. And if I get it wrong, then I get sad. That's it. Thank you very much. Have a great day.